In this video, we're going to look at how to compare different variables using SAS. So before we start, you want to make sure that you have three files. The first one being the file that has the SAS code for this module. You want to make sure to have your code book handy. And you'll also want to make sure that you've got either the data set for Kentucky or the data set for your individual state. Now, I highly recommend following along first with the video using Kentucky and then changing it over to your state for the assignment. So the first thing I'm going to do is read in the data set. I'm going to use the proc import statement. You'll notice for the proc import statement, I have what I want to name the data set here and work dot in front of it. The work dot, that's just an internal directory for SAS, is why we've got that there. You don't have to worry too much about it. But if you're using the import wizard and you want to follow along, this is the name you'll want to give the data set. I also have the file path, and at the very end of this, the name of the file that has the data. So I'm going to go ahead and run this. And again, you don't want to run this if you're using the import wizard. All right. So looking here, I know it says that import was unsuccessful, but it does tell me that we have 2,869 rows. And so to me, that suggests that it actually did read in, because we've got the 2,869 observations and 279 variables. So I think even though we got this, I actually think that we're okay. We can always view the data just to double check. And so one way that we can double check is we can use some of that code we had from Module 5. So I'm just going to paste this in here. And so let's run this and see what we have. Alright, so looking here, I do see all of the variable names, and so I think we're actually okay. If I run into any trouble, we'll go back and try to fix it. So the first thing we're going to do is create a contingency table. So remember that contingency tables give us a way to compare variables. So to make a contingency table, I'm going to use the proc freq statement. We saw this before when we created frequency tables. I'm going to have data equal to the name of the data set, and then the two variables that I want to compare. So in this case, I'd like to compare education to whether or not someone has difficulty walking. So let's first take a look at these two variables in the codebook. So my first one is EDUCA. And just as a reminder, one way to quickly navigate the codebook is you can search. So you can hit Control F to pull up the search box, or Command F if you're on a Mac. So I'm going to look for EDUCA. Here is that variable. Here's the different values it takes and the different levels. And then the other, variable we're looking at is the diff walk variable. And so this variable looks at whether or not someone has difficulty walking or climbing stairs. We see that that takes the values yes, no, don't know, not sure, and refused. All right, so let's create the table. So here we have education along the rows and difficulty walking by the columns. If we wanted to switch those here when creating the table, we would just do diff walk star EDUCA. And then we can see inside of each of these boxes we have several values, so this box right here can be used to see what they are. So the frequency is going to be the count. So there were no people that responded both 1 to diff walk and 1 to education. But there were 209 people that responded 1 to diff walk and 4 to the education variable. The percentage is the overall percentage. And so this would be if we divided by the overall total. So for example, if you take 42 and you divide it by 2,796, and so I'm going to bring up my calculator here, just so we can double check that. If we take 42 and we divide that by 2,796, notice that gives me about 1.5%. And notice here we have 1.5%. The percent is always just going to be whatever the frequency in the box is divided by the overall total. Now we also have row and column percents, and these are actually what you're going to be more interested in when building your table for your report, the row percent, what it does is it conditions on education and looks at the distribution or the conditional proportion for difficulty walking. So for example, for everyone that replied 1 to education, if we look at this, let me just highlight the row, but if we look at these values here, what that does is that tells me out of the people who responded 1 to education, 100% of them responded 2 to difficulty walking. Well, notice there was really only one person in this row anyways, and they responded to 2, so that's where you get your 100%. On the other hand, out of everybody that replied 2 to education, about 45% of them replied 1, 55% of them replied 2, and 0% replied 7 and 9 for difficulty walking. These row percents are what you're going to want for your table for your report. And the reason for that is, what it does is it gives us a way to condition on education and then look at difficulty walking. And if we look here, what you're going to notice is if we look again at that third value in each of these boxes, notice that as we increase education, the percentage of people that are replying 1, which was yes to having difficulty walking, for the most part is decreasing. Now remember that 9 for education is refusal. On the other hand, if we look at the 2s, if we condition on education, we can see that as education is increasing, that conditional percent of no's is increasing. So in other words, there's an association between education and whether or not people are having difficulty walking and climbing stairs. And what we're finding is that as education increases, the percentage of people that are replying yes is decreasing, and then of course the percentage of people that are replying no is increasing. Now the last value is the column percent, and it does the same thing, except it conditions on the difficulty walking. So you'll notice that if you look in this first column, all of the last values, if you added them up, those are going to add to 100%. Similar for this column, all of the last ones are going to add to 100%. So again, these row percents, that's really what you want for your report, because you're going to have your demographic variable represented in the rows and your variable of interest represented in the columns. So this lets you look at different levels for the demographic variable and compare that distribution of your topic variable across those different levels of the demographic variable. All right. Now it's always a good idea, we want to make sure we comment on what our missing values are. So notice here we've got missing values are equal to 73, but that doesn't tell us where our missing values are coming from. And the reason for that is if a value is missing for either of the variables, it won't appear in the table, and so it could be missing for one or both of them. Now we could use what we've seen previously in the course and just create the frequency tables of the individual variables. And if we do that, we can see that all of these missing values are actually coming from the difficulty walking variable. The education variable does not have any missing values. All right, so the next thing we're going to want to do, just like we talked about the frequency table, is let's actually format it so we've got some labels for these. So I'm going to create a formatting variable for education, just like we've seen in the past, and a formatting variable for walking, just like we've done in the past. And again, I'm using the code book to create or figure out what these should be. So I'm going to run both of these. Remember, those don't output anything, that's just creating the formats. And then I'm going to recreate the table we just had before, except I'm going to add in this formatting line. We run this, and notice we have the same table, except now we have some meaningful labels. And so, for example, I can see if I focused on those that had some college, and I looked at those row percentages, and again, these values here should add to 100%, and they do. What that does is that tells me, given that somebody has had some college, about 22.5% of them say yes, whereas about 77.5% of them say no. Now I did realize there is an error in here that should say row, and so that'll be corrected in the version that you have. All right. So the next thing we're going to do is remove some of those non-informative categories. Notice if we look at the don't knows and the refusals for difficulty walking, for almost all of the categories, those are 0, and the categories that aren't 0 are very, very low counts. Remember that we have almost 3,000 observations, so those counts are very, very low. So that's why I'm calling these non-informative. These are really just going to clutter our tables and our plots and make them harder to read. Their counts are incredibly low. So it makes more sense to just remove those categories and then in a footer on the bottom of the table talk about that those values were removed. So we're still transparent about what's in the data, but we're not cluttering our tables and our plots. And so I want to remove the don't knows and the refuse for difficulty walking and the refuse for education. You could also make a pretty strong argument to remove the kindergarten for less for education as well, since there was only one person that responded in that category. All right, so to do this, very similar to what we did with our frequency tables. I'm going to start out with my original data set. I'm going to call it in. I'm going to use this set line, and that just kind of, you can think of that as pulling it forward and making a copy of it. I'm going to set education 2 equal to education. And if education is equal to 9, then I'm going to set it equal to missing. Now, for the difficulty walking one, I really want to remove anything that was a 7 or a 9. And so I'm going to do that by saying if diff walk is greater than or equal to 7, then set it to missing. And so if you've got more than one value you want to remove, this is one way that you can do that. So we're going to run this. And then we're just going to check our contents of our data set to make sure that it added in that diff walk 2 and that education 2. Very similar to what we did with frequency tables. And we do see those are down at the bottom now. All right, so again, for any values that you remove, you just want to make sure that you remove them. So I'm going to add in a comment here, similar to what you could put at the bottom of your tables. And again, these will already be in the file when you get it. Okay, so you could say something like, at the bottom of the table, there were a total of 73 missing values and 13 observations with a response of don't know or refuse for the education or walking variable that were also removed. You could probably, the grammar could be a little bit better there. So where do these values come from? The total of 73, remember that when we came up here, we saw there were 73 missing. And we also know that we're removing the don't knows and the refuse for both of the variables. So all I did to get the 13 was I just counted the frequencies for each of these boxes. So I had 2, brings me up to 4, 5, 6, 7, 8, 13. And so that's how I know that those were the ones that were removed. And that value is probably going to be pretty easy to count just because, remember, again, the reason we're removing these is their counts are so low, they're not really informative. Now, if you find for one of your variables that the don't know accounts for 40% of your data, you probably don't want to remove that one. But for a majority of them, they are going to be very low. All right, so now let's look at this with those values removed. And again, that column, that should say a row. And now notice our table is much easier to read now. We have fewer columns, one fewer row. And now, of course, we never want to just copy and paste these tables into Word. We're using SAS to get those values. And so again, the value that you're going to want from each of these is really going to be the third value in each of the boxes. But now, again, we can compare different levels of education, and based on that level of education, we can look at the distribution of difficulty walking. And notice that, again, like we were saying before, as education increases, the percentage of yeses are decreasing, and the percentage of no's are increasing. So we can see that association. All right, next let's look at how to create some bar plots. So the first one that we are going to look at here is a side-by-side bar plot or a grouped bar plot. So let's first run this and look at what we've got. All right. So here's our first plot. A couple issues with this plot. First, as we look at this one, notice that we've got a lot of options here on the bottom, but really that refused, the bars are very, very low. And again, the same argument can be made for kindergarten or less because their counts are so low. So just like with the table, we probably want to remove these bars. And then also notice for difficulty walking, really above each of these levels of education, there are 4 bars. It's just that the don't know and the refuse bars are so low that we can't even see them. And again, that's because their counts are very, very low. So just like with the tables, we probably want to remove those non-informative categories, put that footnote on there. Here we've got frequencies. We really want to have some relative frequencies to make it easier to compare, just like we were talking about in the tables. So let's see some ways that we can maybe make this better. Now before we do that, but let's look here at the code. So notice now, instead of education, I'm actually going to call education 2 because that's the one with those categories removed, and the same thing for difficulty walk. But other than that, everything else I'm keeping the same. So here we have another side-by-side bar plot. These 2 bar plots are showing the exact same thing, but the bottom one has those non-informa categories removed. And notice that is much easier to read now without all that extra clutter in there, which is essentially what those categories are. Now again, we would want to put a footer on this to say those were removed for transparency, but this plot is much easier to read than the bottom plot is much easier to read, compared to the top one. Now these are the side-by-side. We could also do stacked. So let's compare what the stacked looks like. I'm first going to make one again with that education variable. So this is the one without the non-informative categories removed. So we have these really low bars here. And then notice the legend says don't know and refuse, but we really don't see those in our bars. So again, let's run it now with the education 2 and the difficulty walking 2 that have those removed. And we can see the plot looks much cleaner, the bottom one compared to the top one. Now we still have this issue with the frequencies. We'd like to have those conditional proportions instead. So let's see how we can do that next. And so these are going to be what you really want for your EPI report. Now in order to do this, we first have to sort our data set by our category that we want on the x-axis. So we still want to have education on the x-axis, and for yours you're going to want whatever your demographic variable is on the x-axis. So let's run that. Now it's not going to do anything, but that just sorted the data set in the background, so it's always good to check your log, make sure there's no errors. And then the next thing we're going to do is recreate that frequency table. So notice here, we're still going to have our frequency table by education 2. That's the variable you want on the x-axis. Here we've got our second variable, which in your case would be your topic variable. And then I'm going to output a frequency table. And so you'll just want to give this a name that makes sense for the 2 variables being compared. So what this does is this splits up your frequency table so that it's sorted by the levels of the demographic variable. So here in the output, notice for each level of education, I get a frequency table for difficulty walking, which has levels yes and no because we removed those other ones. So here is all the code to create your side-by-side bar plot. So this is going to be what you want to use for your report. I'm going to run it and then I'll talk about what the different pieces are. So here's what this looks like. So now we've got, again, a much better plot compared to this one, and let's talk about why. So notice that this is going to be relative frequency of the walking variable by education. So for each level of education, these 2 bars are going to add up to 100%. So what this tells me is if I know someone only completed elementary school, about 45% of them say they have difficulty walking, and about 55% say they don't. But by the time I get up to a college graduate, that drops to about 15% saying they have difficulty walking and 85% saying they don't. So I can very quickly look at this plot and see that the higher the level of education, there seems to be less difficulty walking. Now, I can't say there's a causation here, but I can say that there's an association. And this plot makes that very, very quick to see. Now, some things I've got here in the code. You'll notice that I changed the colors. I've got purple and red. So I added this line. The only thing you need to change here are the two different colors. And so that way you can change your colors to match your report. The format line is the same. The V-bar line is the same as before. I've added in my title, and then I've also added in an x-axis and a y-axis. Now we could do the same thing, but instead of having side by side, we could have a stacked. And here's what the stacked looks like. And again, the stack, we can see very quickly that as we increase education, we're decreasing the difficulty walking. And so these plots, again, are much cleaner compared to some of these first ones that we made, and they're much easier to read and much easier to interpret. All right, so at the end here, I'm not going to go through this, but I have some extra code here for how to create scatter plots and regression lines in case you need those later on. For your reports, you're mainly comparing categorical variables based on the nature of the data set, so you won't actually need these for, and that should say module 8, you won't actually need these for your report, but you might need them in the future, and so that's why I've included that code for you here. So as always, if you have any questions or you need any help, please reach out and let me know.